All right, it's time to do some more factoring. So if you are comfortable with everything we did in the last video, it's time to do some harder problems. So here is the first one. So you know by now, we first draw the x. Factors of 4, 1 and 4, and then factors of 3. There are two possible combinations because we can either put the 1 here and the 3 there, or the 3 here and the 1 there. So let's see if we can do this in our head to figure out which one is the right one. If we put the 3 here, then 3 times 4 will be 12. And already we're over 8, so we know that's not the right one. So then the right one must be putting the 1 here and the 3 here, right? So then we'll have 4 times 1 is 4, and 1 times 3 is 3. 4 plus 3 is 7. But wait a minute, we still are not at 8. So how come both of those combinations didn't work? Well, it's because now we are doing problems where the coefficient of the x squared term also has many different combinations. Factors of 4 are not just 1 and 4, there's also 2 and 2. So we tried the 1 and 4, that didn't work. So now let's try 2 and 2. And now we should get it where one of these is going to work. If you put the 3 here, that'll be 3 times 2 is 6. The 1 will be here. That will be 2 times 1 is 2. 6 plus 2 is 8. So that will work. So now this will result in 2x plus 3 times 2x plus 1. Okay, let's do another one like that where we have many different possibilities for the coefficient of x squared in the problem. Okay, 6. We have 1 and 6 and 2 and 3. Now, you might be thinking, well, we could reverse those, right? And then we would have 3 and 2 and 6 and 1. But really, there's no need to test those as long as we reverse the factors of the other one, because we're multiplying diagonally. So when we reverse one side, if we were to also reverse the other side, it would just go back to what we had initially. So we only have to pick one side to try both ways. So let's see if we can take a guess at whether the factors of 6 that we're going to use are going to be 1 and 6 or 2 and 3. If we were to use 1 and 6, then what we would see is if we put the 5 here, that would be 30, so that's way too high. Put the 1 there, that'd be 6. Then we put the 5 there, that would make 11, so that's too low. So it's not going to be 1 and 6. It has to be 2 and 3. Now, let's see if we can quickly get to 17. If we were to put the 5 here, that would only give us 10, and then the 1 would be here. 3 times 1 is 13. So the 5 has to go on top. 5 times 3 is 15. 2 times 1 is 17. So this will be 2x plus 5 times 3x plus 1. As you can see, we're doing these a little faster now with more practice, you should be able to do them at this speed as well. But we have a lot of problems to cover here, so I do want to speed up a bit. Okay, now this one is going to be challenging because we have many different possibilities for 9 and for 4. Okay, let's see if we can take a guess for the 9. It's either going to be 1 and 9 or 3 and 3. Think about this in your head. Let's say we had 3 and 3 for the 9. We would then have the highest factor for 4 could be 4, and 4 times 3 would be 12, which is nowhere near 20. So we're going to, based off of that, say that 3 and 3 is not going to work because we can't get high enough. And we're going to start right away with 9 and 1. Now, we have to decide what factors we're going to use here. Where are we going to, if we were to try 4 and 1, we put the 4 here. That would be 36. That's way too high. We put it there. That only gets us to 4. That's way too low. So without trying those, we're going to assume that this is going to be the other factors of 4, which are 2 and 2. And if you look at that, that's 18. That's 2. That adds to 20. So without having to try tons of different possibilities, even though there were dozens and dozens, we were able to, through some reasoning, figure out which one was the right one pretty quickly. And that's what makes this method so fast. If you can do it like that, figure out the right numbers to put on this X in your head, then you can do these problems very quickly. Okay, now for this one's a little tricky. We have many different combinations for 6, many different ones for 8, and 26 seems like it'd kind of be right in the middle. So for this one, it's hard to guess what we should start with. Let's just start with 1 and 6. If we were to use 1 and 6, in order to get up to 26, what number would we have to put across from the 6? It's one of the factors of 8. It's either 1, 2, 4, or 8. Well, if we put 4, that would get us to 24, which is pretty close to 26. So let's see if that works. That's 6 times 4 is 24. Then the other factor of 4 to get to 8 would be 4 times 2. Now we have 24. This is 2. 24 plus 2 is 26. So it turns out that works. Okay, now it's time for a real challenge problem. If you notice, these are definitely getting harder, even though we're doing them pretty quickly. But this one's going to be tricky because now 12 has a lot of combinations. 1 and 12, 2 and 6, 3 and 4. And 15, we have 1 and 15 or 3 and 5. And then, of course, those can be reversed. So look at this. 12 and 15, these are pretty high numbers. Now, 29 is also pretty high, but in comparison to 12 and 15, it's actually fairly low. So that's a clue that we might want to not have any crazy high numbers in here like 12 or 15. So let's start with the lowest numbers we can get for 12, which would be 3 and 4. Now, the lowest numbers we can get for 15 are going to be 5 and 3. It's just a matter of where to put them. If we put the 3 here, that would get us to 12, which doesn't really seem like we're going to be able to get high enough. So let's put the 5 here, and then we'll put the 3 here. This will be 5 times 4 is 20. 3 times 3 is 29. There we go. Now, I'm doing these problems pretty fast here because I know what the answers are going to be already. If you're doing them, you might take a little longer, try a few more guesses. You're not always going to guess right on the first try, but you don't want to just... The important thing is you don't want to just start picking random factors and getting numbers that are way off. You want to try to do them in as few guesses as possible. Okay, now this one looks very difficult, but before we even start, there is something we can do with this one. In fact, this was the case with previous problems as well. I just didn't want to do it there yet in order to make the problems harder. But with this one, now I'm going to show you, you can reduce the whole thing before you even start factoring. Look at the coefficients, 4, 50, and 24. If you notice, all of them can be divided by 2. So let's go ahead and do that. They're all even numbers. When they're all even, they can be divided by 2. There we go. Divide the whole equation by 2. Now we're just going to factor this one. This one's a lot easier because we just have 2 over here. So the only factors possible are 1 and 2. Now for 12, if you notice, these numbers are very low. So in order to get all the way up to 25, we're probably going to have to use a pretty high factor. So that means we're going to be using 12 and 1. Now where should the 12 go? It'll count more if it goes across from this 2, right? So we're going to put the 12 there. That gets us up to 24. The other factor of 12 would be 1. 24 plus 1 is 25. So this works. X plus 12 times 2x plus 1. All right, and here is the last one for this video. Again, the entire thing can be simplified. What number do you notice it can be divided by? Well, all of these numbers, 15, 24, and 9, are multiples of 3. So we can divide all of them by 3. Of course, you could factor the equation at the start, but it's going to be a bit easier with lower numbers. So if you can simplify, you probably should. This one's actually very easy compared to the others. Only factors of 5 are 1 and 5. Now the question is, where does the 1 and 3 go? If we put the 3 here, that'll be 15. That's too high, so we're going to put the 1 here and the 3 here. This will be 3 plus 5 is 8. And we write it out as x plus 1 times 5x plus 3. All right, we're going to stop there. And part 3 in this series of videos on advanced trinomial factoring will be next. That is where we will introduce negative numbers, and the problems will once again get harder. So I encourage you to do lots of practice with all positive numbers before you move on to harder ones with negatives.